Okay, so hi guys, welcome back to my channel. So from today onwards, we are going to start a new design patterns, which is behavioral design patterns. And among those three patterns that I have told in the beginning that we are going to teach in this playlist, that creational design pattern, structural design pattern, and behavioral, which I consider is the most important. Okay, creational design patterns I have already covered. You can check out my playlist. All the patterns I have covered with examples. Now we are going to start the behavioral design patterns, and that too I am going to start with the command pattern. Okay. Next will be the chain of responsibility. So starting from the command pattern. So we'll see the definition, what the command pattern is all about. Then we'll move to the code examples and without command patterns, how we used to code and what are the problems that we have faced so that this command pattern has came into picture. So let's read the definition. So the definition is saying that a command pattern is a behavioral design patterns, okay, that converts a request into a standalone object that contains all information about that request. Okay, now let me tell you one thing, what command pattern is all about with a small info. Okay, so let's say there is an object O, it is calling get money. So when an object is calling this get money method, then what is happening? Okay, this method can execute some action. Okay, let's call this thing as an action. We have called an action. So when this action is being called, there is no track what is getting called or what has called previously. Okay, so the whole idea is we do not have any track what we have actually performed. Okay, so command pattern says instead of calling this action directly, let's convert this in an object and execute it later. Okay, so converting an action into an object is what command pattern is all about. Okay, so the whole idea, whole explanation will revolve around this, creating an action to an object. So that what is the benefit of creating an action into an object? As we all know that we do not have any track of this action once it is getting executed or once it got executed, but when we convert it as an object, we can store it, we can utilize it for our further use. Okay, so we have command of all this object. Okay, but we do not have the command on this action. Okay, so this is the point of command patterns. Okay, so let's read the definition further. So it is saying instead of directly calling a method on an object, we wrap that request inside a command object and execute it later. Okay, the same thing which I have explained now. Okay, this pattern encapsulates a request. This pattern encapsulates a request as an object, thereby allowing you to parameterize clients, okay, with different requests, queue requests, log requests, support undo redo operations. This is the very interesting part of this video. I am going to explain this, how undo redo pattern is getting implemented, what is the logic behind it. Okay, the command pattern is the one that is behind side of this undo redo operations. Okay, now moving forward, why this command pattern is even introduced. So imagine you are building a remote control. You have TV, fan, AC and music system. Without command pattern, this is the simple implementation that I have done. Let's say you have a TV. Okay, implementing first for the TV. So let's say you have the TV, you have created two methods, which is turn on and turn off. Okay, turn on is simply printing TV turn on and turn off is printing TV turned off. This is the remote class that I have created. With the help of this remote constructor, I am initializing the TV object. Okay, now I have created two methods, which is remote.press on button, remote.press off button. Till now this is clear. This is the client call that we are doing. We have created a TV object, we have created a remote object and pass this TV inside this remote object so that the constructor can take this TV and initialize this TV class. Now as soon as we do remote.press on button, the control gets here, remote.press on button, and it will call TV.turn on. Since we have initialized this TV as an object, TV.turn on will be called and it will print TV turn on. It will print TV turn on. Same as with remote.press off button, it will call this press off button, TV.turn off, it will call TV.turn off and turn off will be printed. Till here everything looks fine, but as soon as this command gets executed, we do not have any track that what we have executed earlier. Now the problem is it isn't about like we are not storing that action somewhere, so we have created this command pattern. Command pattern solves many problems. Okay, now the client says add fan support, add AC support, add music system support. So again we need to do just like we have added this TV class inside this remote, we need to add the fan support also, we need to add this AC support also. Now more device means more modifications. So remote becomes tightly coupled with every device, and this violates the open close principle and loose coupling. What open close principle says? The class should be open for extension but closed for modification. But we are doing modification inside the remote class. Okay, that violates the open close principle. Now instead, the sender remote should not care who is receiving the request. Okay, this is why command pattern is introduced. I'll go deep dive in this, don't worry. Okay, now let's see the deep dive, what problems that we face without the command pattern. So the problems are, the action is something like tv.turn on, as we have seen, and tv.turn-off. These are the two actions. Normally you just call the method directly. The action is tied to the receiver TV. Normally when we do that action, it is tied to the TV. In this command pattern, instead of calling the method directly, you wrap that action inside a separate object. What this means, like turn on command, turn on TV command. Now, so what abstracting actions into object means, we take a method call and represent it as a standalone object. Okay, we take a method call just like tv.turn-on and wrap it inside the turn on TV command, which is a separate standalone object that can be passed around, stored, queued, and executed later. Okay, as soon as we convert that action into an object, now the ball is in our court. Now we can pass it around, we can store it, we can queue it, or execute it later. Okay, without abstraction, we'll do tv.turn-on, tv.turn-off. Here action is not abstracted, it's just a method call. With abstraction, we'll do command on command is equal to new turn on TV command. We have discussed earlier that tv.turn-on can be converted into a standalone object, which we have done turn on TV command. Okay, now remote is equal to new remote. We have created a remote object and we are passing the remote.set command on command. Now this command can be passed inside the set command to be executed. Okay, now here the action tv.turn-on is wrapped inside an object turn on command. Okay, the remote doesn't know about the tv.turn-on, it only knows the command.execute. That's abstraction. The action is now represented by an object command, not a direct call. Okay, so we have successfully converted that action into an object, and we are passing that command inside this set command so that it can be executed. Okay, now why to do this? At first it feels like, okay, so we have tv.command A, tv.command B, tv.command C, tv.command D, and many more commands. So isn't it like cumbersome that for every action we are converting into an object A, object B, object C, object D? So isn't it cumbersome? So at first it feels like extra classes for nothing. Okay, but abstraction gives you power. You can store that commands inside the list, replay them later. This is the main crux of this command pattern, or main power of the command pattern. As soon as the action is getting converted into the object, you can store that command in the list and you can replay this later. Okay, you can undo redo, which is the best thing which I have ever seen. Initially I was also surprised that how undo and redo is getting implemented, which pattern it is following. But as soon as I have got to know that okay, the implementation behind this undo redo pattern is the command pattern, so I got amazed. I'll show you one implementation, one code example of this undo redo pattern. Now you can undo redo because each command knows how to reverse itself. Okay, just because we have converted that action into an object, we can store it, so we know that how to reverse itself. We can swap commands at runtime without changing the invoker remote. Okay, you can queue commands for batch execution. So these are the powers that command pattern will give you. Okay, so now moving to the components of this command pattern. Why this is important? Because whenever you are given with a problem statements, you need to know these components in order to implement the command pattern. Okay, so you need to have a careful understanding of these components. Okay, so let's see the first one. Client creates command object. The client call is the only one or is the only place where we create the command object. Okay, this is the command interface. Second one, this is the client which creates the command object. This is the command interface. This is the concrete command. So whatever class we are creating that implements this command will lie under this concrete command. This is the receiver. Okay, actual business logic, what actually actions do is implemented in this receiver. And invoker is what? Invoker don't care that what command it is, like turn on TV, turn off TV, anything. Okay, invoker just execute the command. Okay, so I hope till here it is clear. So moving forward, let's see the code example, the basic code example, which will give you a clear idea of how you can implement this command pattern. So let's revise these components by seeing this code example. Okay, so this is the command interface. Okay, now this is the you all can tell me what is this. I'll leave it on you. Okay, later I'll explain you what is this. This is just because it is implementing the command, it is the concrete command. Concrete command. It is the concrete command. Now same, this is also the concrete command. Okay, because these two are actions. Okay. Now moving to this remote. What is this remote? Again, I'm leaving it on you. What is this? This is the client. Why this is the client? Because client is creating the command. Okay, here this command, object or command. So because of that, this is known as the client. Now, as I have told you, there are 5 components. Okay, command, concrete command, invoker, receiver, and client. What is invoker and receiver? Receiver is the one which is having the business logic. Okay, and invoker is the one who executes the command. Can you see this? In this class, we are actually executing the command. So this is the invoker. This is the invoker. And in this example, we are actually writing the business logic, what turn on command will do, what turn off command will do. So this is the receiver. I hope this is clear. I hope this is clear till now. I'll quickly show you the code flow because I have other 3 examples with me which I also have to explain. Otherwise this video will be very long. So we have created a TV, we have created a remote class. Inside this remote, we are setting command, okay, set command, and we are passing this action as in command. What we have told, instead of doing this TV.turn-on, we have converted this into an object, new TV turn on TV command. Inside this, we are passing TV. As soon as this object is getting created, the constructor is called, okay. Which constructor? TV.turn-on. This constructor is called. This TV gets initialized with this TV, okay. The TV class gets initialized with this object. Okay, now remote.set command, the flow comes here. Remote.set command, set command, we have passed this command which is nothing but an object. So this command got initialized. Now what we are doing? Remote.press button, this part. So remote.press button, command.execute. What is the command? Turn on TV command. So turn on TV command dot execute will go here. Turn on TV command dot execute, this one. So TV dot turn on, as we have already initialized this TV, so TV dot turn on, okay, TV dot turn on will get TV turned on. This get printed here. Same the implementation goes with this TV turn off TV command. Okay, the same implementation. I'm not going to walk you through this. Okay, you all can see and you all can write and you will get the clear picture. This is the UML class diagram of this simple example. Now moving forward, so let's see the real world usage. So the first one is undo redo pattern, which is very interesting part of this command pattern. Okay, this MS Word, Figma, VS Code all have this undo redo pattern. This task scheduling, Spring scheduling, Jenkins jobs, all using this command pattern. Cube processing, RabbitMQ, Kafka consumers, SQS. These are some of the real world usage. Now let's see 2 examples of this command pattern, which is very important. Okay, if you'll understand this, you'll never face any problem in order to implement this command pattern. Okay, so the first example is banking statement, which is undo transaction, and second example will be the text editor, which is the undo redo pattern. Okay, so I'll explain you both. So starting from the bank system. So before starting from the bank system, you all can revise what all 5 components that we have learned. Okay, the first one is command. Second one is concrete command. Okay, the third one is invoker. The fourth one is receiver. The fifth one is client. Receiver, which actually has the business logic. Okay, invoker, which executes command. I hope these are the 5 commands that you are familiar with and you will be helping me to go through or walk me through the code. Okay, so what is this command? This is simple command. Okay, this is the receiver. Why this is the receiver? Because this is having the actual business logic, deposit, withdraw. Okay, just because of this, bank account is the receiver. This is the command, concrete command. Why? Because this is implementing the command. This is also the concrete command because this is also implementing the command. This is the invoker. Why? Because this is executing the command. Okay, command.execute, you all can see. Okay, I hope till here it is clear. Let's do the dry run and we'll get a clear picture how this code is working. Okay, so now let me walk you through the code starting from the client code. So first we have done receiver. Bank account is equal to new bank account. As soon as you do new bank account, the constructor will be called and 1000 rupees will be set. So balance is equals to 1000. New bank account balance will be 1000 just because of this constructor. Okay, moving forward, transaction manager, which is nothing but the invoker. Now manager will call dot execute. Inside this dot execute, we are passing the command, which is nothing but an object. New deposit command, account and 5000. So as we'll do deposit command, the constructor this will be called, and account is equals to account will be initialized. Let me not write this. So bank account is equals to new bank account will be initialized. Private int amount is equals to 5,000, which is also get initialized. Now as we'll do manager.execute, the call will go here, manager.execute. It will reach here command.execute, which is what is the command type? Deposit command. Command.execute, deposit command.execute. It will go here, as because we have already initialized this bank account and amount. Account.deposit amount will be called, which is nothing but 5,000. We have passed 5,000. Okay, account.deposit 5,000. This bank account will be called account.deposit balance plus is equals to amount, which is nothing but 5,000. We are printing the balance. Current balance is 6,000. Okay, why? Because 1,000 we have already deposited. Now after this command get executed, we'll push history.push command. We'll do here. What command we have stored? History.push command. What is the command? New deposit command. So in short, I'll write deposit command, which is nothing but account comma 5,000. This is stored in the history stack. Okay, I hope till here it is clear. Now next, moving to the manager.execute new withdraw command, which is account and 5,000. Now in this withdraw, we will see with the help of this constructor, this got initialized. Okay, this got initialized account and amount. Okay, now in this execute, what will happen? Command.execute. So withdraw command.execute. So we'll see withdraw command.execute here. So account withdrawn amount. Amount is again 5,000. Now account bank account dot withdraw amount is 5,000. So balance minus equal to amount minus 5,000, which becomes again 1,000. Okay, which becomes again 1,000. So as soon as this command.execute will be called, the balance will be printed as again 1,000. Okay, 6,000 we have printed, we have seen, it becomes 1,000. Now again history.push command. So the command is withdraw account comma 5,000. I hope till here it is clear. Now as soon as we do manager.undo, what it will call? Manager.undo will be called. It will check whether history is empty or not. History is not empty. Okay, then we can perform the undo operation. So we'll execute, or we'll pop the top from this stack. Okay, so we'll get here withdraw. Okay, we'll get here withdraw. Now command.undo, withdraw.undo. Okay, withdraw.undo, this will be called. As soon as we'll do undo, account.deposit, because we have withdrawn the amount, so the logic is like we need to deposit the amount. Because we have withdrawn the amount, we'll do undo, we need to deposit the amount. Amount is 5,000. So account deposit will be called, and again from 1,000 it will add the amount plus 5,000. Because we have withdrawn the amount, we'll do undo, we'll adding the amount 5,000. Again it become 6,000. Okay, so I hope this is clear how this undo pattern is getting executed. Okay, and how this banking system undo transaction works. Okay, I hope this part of code is clear. Now moving to the text editor. Okay, this is the undo redo pattern, and this is very important. Okay, so let's start. So again, so just repeat with me all the components. So the first one is command, the second one is concrete command, the third one is invoker, fourth one is receiver, fifth one is the client. Receiver have the business logic, invoker who executes command. Okay, now start with this code example. So this is the command. Okay, this is the command. Let me change the pen size. So now starting from here, this is the command. Okay, so this is the receiver. Why? Because this is containing the actual business logic. This is the concrete command. Why? Because this is implementing the command. Okay, this is implementing the command. Now this is the invoker. Why? Because this is calling the execute command. Okay, and this is the client code. Okay, so let me walk you through the code starting from the client. Okay, just listen it very carefully, because this is the undo redo pattern. Okay, so I have created a text editor which is nothing but the receiver. Okay, I have created a editor manager which is nothing but the invoker. So inside that invoker we are calling execute command, add text command, editor comma hello. As soon as this add text command is called, editor gets initialized, text get initialized. Okay, now we'll do manager.execute. Here we are with the manager.execute. Where is this execute? This. So before that, let me create two stacks undo, and one stack is redo. This is undo and this is redo. Okay, so command dot execute, we have add text command. So add text command dot execute, add text command dot execute. Now editor dot add text. So editor dot add text editor, this text editor dot add text is hello. So content, now the content will contains because add text is appending the text. Okay, content will contains hello. Okay, the size of the content is 1 2 3 4 5. Now moving forward, as soon as this command dot executed gets completed, undo dot push command, inside this undo we are passing add text command and we are passing hello. In short I'm writing now and redo dot stack clear, okay. Now because we have again passed add text command editor world, okay, again the call will come here, command dot execute, again the call will come here, execute. Now we have world. Remember one thing, we have passed the space inside. Okay, so again the content add text will be called and the content will be appended here. Let me append the content. The content will now become, with space it becomes world. Okay, now this is 6 characters. Now what will happen, the interesting part. Now manager dot undo, as soon as this undo will be called, it will check whether the undo stack is empty or not. Okay, before that I forgot to push this world and again clear this redo. Okay, now it will check that if undo stack is empty, no, undo stack is not empty, will pop this etc world. Add text command, we have add text command world with us as in command dot undo means add text command dot undo, the code flow will go here. Editor dot remove text length, which is nothing but 6, editor dot remove text, which is nothing but we are passing the length as 6. So content length is now 11 minus length as 6. So we have passed at the beginning 5. The first parameter is 5. Content length is 6. So from the fifth one, from the starting, okay, from the starting, we need to remove this part. So this part will be removed. Okay. So content dot delete will remove the world. Okay. Now system dot out dot println. So world will be printed. Hello is getting printed. World will be printed. I forgot to as we have executed this undo, we need to pass the redo dot stack dot push command. Okay. Let me remove this. And we need to pass this etc world inside this. Now we need to do redo. So the call will come here inside this redo dot is empty. Okay, no, redo is not empty, we have the redo stack. So we'll pop the element which is nothing but etc world. Again we have etc world. Command dot execute this add text command dot execute, this will come here. Editor dot add text, now we again have world. Okay, add text. Now since we have removed the world, we will be adding world again. Okay, now the content again will become hello world. Now since we have done the redo, we'll pass it in the undo stack dot push redo. So again I'm just crossing here because the same thing we are going to append here, which is nothing but world. So the same way this will be executed. What are, since we have appended what, so hello world what will be called, we are again appending r is called. We are doing undo, r will be undone. Again undo, what will be removed. Again redo, what will be added. Again redo, r is added. So I hope this flow is getting cleared. So I'll suggest you to go with the code and do the dry run 2 or 3 times so that you will get a clear picture of how these components are executed and how you can implement it. Okay. So now I hope the banking system and text editor example is clear. So let's move to the deep understanding. So the real reason command pattern become famous in the enterprise system is because the command is an object. This is the whole crux of this command pattern. And once something becomes an object, you can store it, you can queue it, you can retry it, you can serialize it, log it, schedule it, send it over the network, or whatever you want to do with that object. Okay. Normal method call email service dot send email. Once you executed, gone forever. You cannot put it in a queue. You cannot save it in a database. You cannot retry it later. Okay. So some of the facts: undo, redo and message queues are actually powered by the same code idea, which is stored work as an object. Every job scheduler is conceptually executing command.execute at later time, which is why? Because this is the job scheduler. A Kafka topic can be viewed as a giant distributed queue of commands, events waiting for execution. Command pattern is one of the few design patterns that scale from TV remote to Amazon processing, Netflix notifications, Uber ride dispatch, banking workflows. So this is the power of this command pattern. Now, because command pattern converts an action into an object, once an action becomes an object, you can store it, you can persist it, you can serialize it, you can queue it, you can retry, etc. A normal method call disappears after execution, but a command object represents future work and can live independently of the caller. Okay, this is the definition of this command pattern. Moving to the final code examples of this command pattern, which is nothing but the e-commerce application. We'll reserve an inventory, we'll send notification email or confirmation email, we'll generate an invoice. Okay, if we execute immediately, it will call inventory service.reserve, will call email service.send, will call invoice service.generate. But the problem is, if the email service is down, we'll forget it, we'll forget the execution, maybe slow, user has to wait. Instead, we create commands and put them into a queue. Okay, this is the solution. Now I'll walk you through the code. Okay, I'll not go deep dive, I'll just go through the overview of this code, because I have already explained you 3 examples and that too very deep. So I'll suggest you walk yourself throughout the code and get a clear picture of how this code is working. I'll give you a overall idea. Okay, so this is the command, this is the command interface, this is the receiver. Okay, this is the receiver. Why this is the receiver? Because this is having the business logic. Okay, this is also the receiver. Why? Because this is also having the business logic. And here this is also the receiver. Why? Because this is also having the business logic. This is the concrete command 1, this is the concrete command 2, this is the concrete command 3. Why? Because this is implementing the command. Okay, this is the invoker method. Why? Because this is executing the command. Okay, now starting from the client, okay, we have the 3 service. What is 3 service? These are the receivers, actual business logic. This is the invoker, 3 receivers, 1 invoker. Okay, now processor.submit, invoker will call submit. First we have passed reserve inventory. Okay, invoker.submit will pass reserve inventory. Queue.offer command. Okay, in this queue will be passing inventory service with the iPhone 17. What will do? Queue.offer. So now we have stored it in the queue. Queue.submit send email. Okay, reserve inventory, generate invoice. 3 are called processor.process. What will happen now? While queue is not empty, queue, the pointer is pointing here, will do command.queue.poll. This will be polled. Okay, command.execute. What is this? Reserve inventory. Where is this reserve inventory? Where is this reserve inventory? Here, reserve inventory. This will call execute service.reserve item. What service? Inventory service. Where is this inventory service? Inventory service dot generate. Oh, sorry, I'm so sorry. Where is this inventory service? Here. Inventory service dot reserve item. It will call inventory reserved for product. It will call inventory reserved for product, which is iPhone 17. Okay. Again, queue is not empty. We have popped this. Now the one is send email. Okay. Send email dot execute. Where is this send email? Send email dot execute service dot send email. Email service dot send email. Email which we have passed is om@gmail.com. Email service dot send email. Email sent to om@gmail.com. Email sent to om@gmail.com. The third one is, again our queue is this. Again our pointer is here. Generate invoice. Again command dot execute. Again invoice service dot generate invoice. Okay, because this is the type of generate invoice. Generate invoice dot execute. Generate invoice dot execute. It will call service dot generate invoice. Service is of invoice service. Invoice service dot generate invoice. Printing invoice service generated for order ID. Invoice service generated for order ID, which is nothing but 101 we have passed. Now why this catch pattern is, there can be a possibility that the current point of time any service is not available. So what we'll do, if it is a failure, we'll print execution failed and we'll do queue.offer command. Since we have popped this command, we'll again push it in the queue. Okay, this is the complete idea of having this try catch block. I hope this is clear. I hope the command pattern is clear, and I hope I am able to convey it properly. and very crystal clearly I am able to explain you all that how command pattern is implemented, what is the whole idea of this command pattern. And with the 3 examples I have shown you, whenever you got a problem statements, how you can move slowly and implement this command pattern. So always remember this components, you'll never forget, and you'll never feel hard to implement the command pattern. I hope this is clear. So thank you for watching and having patience. So thank you so much.